Hey everyone, this is the AI Hardware Show. We are in the after party. Every time we do one of these AI Hardware shows, we have a 30-minute plus freeform chat about the hardware we've just spoken about, because sometimes we have hot takes. My name is Ian Cutress. I'm from All the More, and joining me as always, Sally from E-Times.
Hello.
And this episode was interesting because the previous episode we just recorded, depending on which order these go out and which ones you guys watch, that was mostly about inference. Got a lot of big silicon, some of it training in this one.
Yeah.
And I think one of the things to realize in this industry is that not everybody will succeed.
Yeah.
Right? We said in one of the episodes, there are at least 90 companies on my list. There's about 150 on yours, and it depends where you draw the line, right?
Yeah. So what is a research project and what is a company in some cases?
And do you count everybody in Taiwan and China? And
do you count everything that can do AI as an AI accelerator?
Yeah.
The answer to that is no.
But it does mean that some companies will be acquired.
Yeah.
Some will fail, and some will do both. And this is an example of one that has done both. Intel Spring Crest. Now, Intel's acquired a lot of companies over its time, and the main ones I've been focused on are the AI hardware accelerator companies. Movidius, which still kinds of exists. If you've seen the episode we talk about Keen Bay. There's Habana, which is the big one right now. There's Goya, Gaudi, Greco. And then there's Nirvana, which is kind of dead. There's also Mobileye, if you count Mobileye's IQ5, IQ6 or self-driving.
Your Intel Xeon CPUs have AI acceleration in now,
and
extensions for that, but
yeah,
it depends where you draw the line. Still a CPU, so not in this program.
Intel Xeon, second biggest selling AI hardware after NVIDIA.
Not in this program.
No, not in this episode. No. But so Spring Crest was an exciting chip when it was announced because from the Nirvana acquisition, you had Spring Crest. There's also, I think it was called Spring Hill. It was two chips. One was meant to do training. One was meant to do inference. And they were neural network processors. When you come through an acquisition, you think, right, okay, we're going to get more funding. We're going to get more optimized. And Nirvana was like on its second generation silicon just as Intel acquired them. And, this is essentially what Spring Crest was. The NNPL, the L was for learning, the T was for training. And the whole point here is, at a time, we've said before on the show, if you've seen previous episodes, AI has gone in stages. 3 years ago, convolutional neural networks was the thing. And now recently it's transformer networks. But if you come up with a convolutional neural network training chip today, you're not going to get anywhere because, convolutional neural networks were great video. It's the transformer networks that do great for natural language processing and also for video today. So it's a very fast-paced market. With Spring Crest, they focused on essentially maximizing data reuse through the architecture, through the software, through the gigabytes of HBM memory. The idea is that you could have these large matrix multiplies, large matrix multiply units, and have very high utilization compared to a smaller device that can only process matrices that are only so big and then hard to partition, and you get overhead and complexity with memory bandwidth on that front, and you only reach 80% utilization at 9 times the size. And this was the whole point about that acquisition, that chip. We can support large matrix multipliers because we have tons of matrix multiply units. The AI hardware, the AI software industry, or the models, didn't go down that route. We've always said, especially with, say, systolic arrays, right? There's the right size for a systolic array. You make it too big, and it means you won't be energy efficient with small networks. You make it too small, and you have to partition too much, and you have additional overhead. This is why Google's TPU has switched between multiple sizes of systolic array. When it comes to matrix multiplier units, a similar sort of thing applies. And I think, as you know, a couple of top chip designers have said, you can't just add matrix multiply units and hand tune benchmarks to succeed in this space.
No, not anymore.
And whether it was a combination of people leaving or the reception or the acquisition of Habana.
Yeah,
you know,
the Habana acquisition happened around the same time as
Yeah.
this stuff got canned. So it's easy to read a lot into that, but who knows?
Naveen Rao knows.
Well,
And yeah, I get a feeling he's not Intel's biggest fan anymore. But Spring Crest, the thing is, I remember it being presented at Hot Chips, and it was hot shit.
yeah.
Right? Lots of people spoke about
yeah.
it. There's lots to write about it. They went in detail into the design, and the whole thing is when you have an NPL for learning and an NPT for training, it's this combined approach. You can have chips on both sides of the fence. This is what was going to attack NVIDIA.
Yeah.
No. Deaded. But
had they not been bought by Intel, would they still be around? Intel obviously made that kind of final decision, but if they had gone somewhere else or still been a standalone company, would they still be around somewhere?
Well, Intel didn't even sell the IP.
Right, yeah.
They canned it.
Yeah.
Right? There's a... Intel recently canned the Tofino networking project as well, rather than sell it. And you're thinking, well, surely if there was value...
Yeah, just sell it to somebody else or spin it out or...
Or, seems to be more cost-effective just to can it. And it was annoying because I don't think we ever saw a commercial distribution of Spring Crest. Whether either to B2B companies or hyperscalers, and it's a shame because it's now becomes, I guess, a rare piece of silicon to have in your collection. If you if you happen to have a silicon collection, I wonder who does. But yeah, it's, I don't know, sad to see it go, because now to a certain extent it does paint Intel as a company where AI hardware might go to die. But
I think that's a bit harsh.
In retrospect, it is. I kind of didn't want to say it that way. I couldn't think of the word, but yeah, if Intel comes to you, an AI company, and says we want to buy you, do you want to be the fourth company that
they've acquired that still isn't? Yeah.
It's if they ever decide to separate out their AI revenue in the financials. I mean, NVIDIA, at least data center GPU is used for two things: compute or video processing, right?
Yeah.
Now Mellanox, obviously, that makes it a bit more complicated because you've got networking and stuff.
Yeah.
But you can see that there's, multiple billions of dollars per quarter demand for this.
Yeah.
And it's unclear how much of it on Intel's side that's CPU versus anything else, because they rolled in PSG into that group as well.
Right. Okay.
The programmable solutions, Altera stuff. I don't know. Maybe it's a management thing.
I want to know.
Speaking of Altera, because this is a great segue
into our next one that we're going to talk about, which is Xilinx, the biggest competitor of Altera. No,
market leader.
Xilinx, as I'm sure we all know, just been acquired by AMD. So
it's at $46 billion.
Yeah, it's kind of the AMD version of the Altera.
It's almost been a year now.
Has it really?
Since the deal closed, yeah.
It seems very recent. Seems like it's in recent memory.
Yeah.
So with the FPGAs, they are trying to make an AI play with it. And what they are doing is adding some accelerators as well as programmable logic. And then there are hardened engines kind of in it as well.
Well, so FPGAs have been used for decades for specialized compute.
Yeah, absolutely, yeah.
And one of the uses was computer vision, which is like AI before machine learning, before neural networks.
Yeah.
You actually had to hand/hard code image detection.
Absolutely, yeah.
It was difficult, it was inaccurate, and CPUs were slow. GPUs didn't exist
Get
in
an
that
FPGA.
form. So you'd get in an FPGA. It was still very difficult, but at least you had the optimized hardware for the solution. And that market, well, disappeared to a certain extent with...
Well, it changed.
Yeah, it changed.
With the beginning of AI and this kind of sprouting up of all these other little companies.
But I think the concept of an FPGA changed as well.
Yeah.
Right? The historical view of an FPGA is just as much programmable logic, as many logic gates, logic engines, no matter however you clarify them, as you can fit onto a chip. And then slowly and surely, they've been adding hardened IP, SoC-like. Whether that's Cortex cores, whether it's DSP engines, whether that's I/O, Ethernet, AXI, whatever, and now AI engines. To a certain extent, these don't feel like FPGAs anymore. They feel like SoCs
with a bit of FPGA on.
But the bit of FPGA is the biggest bit.
Yeah.
Right.
Yeah. And so if you need I/O and all these other things, it is more efficient to just have that in hardware rather than try and implement the entire design in programmable logic.
Yes.
So it makes sense from that perspective. But I see where you're going with this. Yeah. Which bit is the biggest bit anymore? And at what point is it just an SoC?
Well, I mean, so Xilinx, the Versal chip that you discussed, the ACAP, which is a little bit of a weird name, application.
So it's adaptable compute acceleration platform, but there are all different ones, and not just the AI one within this ACAP.
Well, so
they have more like DSP optimized ones and so on.
It's like the CPU industry with the integrated graphics, right? You have some chips have some number of CPU cores, some chips have some number of GPU cores, some chips have some amount of I/O, and there are multiple different versions depending on whether you want a CPU focused, GPU focused, or an I/O focused. And the FPGA market is that, but with an FPGA block, right? But but the thing is, because the FPGA block is there, that now becomes the defining point of the chip, rather than just another acceleration path. So this has got me thinking, right? Slight detour. Intel acquired Altera in 2015, 2016, 15, and the question is, when are we going to get FPGAs on chip? When are we going to get FPGAs on chip? They did like a Xeon scalable, dual socket kind of thing with an onboard RA10 FPGA, but that was an external chip. It was never built into the silicon itself, and you could argue there are reasons for that. Maybe FPGAs require different metal stack and what have you in order to work. But it was always thought of that at some point you're going to have a CPU, either server, consumer, and both chips have accelerators, right? Whether it's video decode or accelerating AES instructions for crypto. Well, maybe there's just like this little FPGA block that, with the right library, you can submit the bit stream to change the configurable logic to do the thing you need, and then it goes back to normal. And we've not seen that yet. And in that time, we've had AI engines come out of nothing.
Yes.
And they're already coming into CPUs. Yeah. AMD and Intel both announced AI engines for CPUs.
Yeah.
And yet we still think of FPGAs like the ACAP as FPGAs, not SoCs.
It's definitely an FPGA, yeah.
Yeah.
It's definitely different.
It's because it comes from an FPGA company as well.
Yeah, but they shouldn't really... I mean, it's very difficult, having known about and been writing about Xilinx and Altera for a long time, to think of it in any other way than an FPGA. So to me, this is an FPGA with an AI engine kind of on it.
Yeah.
Not the other way around.
Yeah. SoC. It's because it's not the host.
Could be.
If it was the host and not the device.
Could be.
So, the whole point about dedicated AI logic on this is because, again, if you need it, it's better to have it hardened.
Yes.
Because
you're going to do some AI. Yeah, it's better to have it hardened there.
And then if you want additional security, or if you need more AI resources, you can convert some of the programmable logic.
Yeah, or maybe you have some fancy pre-processing that you need to do in FPGA, depending on what you're working on.
5G, telco is a big thing for that.
Definitely,
Oil, gas.
Definitely.
I mean, it's one regret. The one regret. Regret's not the right word, I guess. The thing I think I miss out on is that I've never taken a quote course to learn how to program FPGAs.
Right.
I never
You
did.
shouldn't need to.
No, I shouldn't need to, but I was a chemist. I wasn't a computer scientist, so I wasn't really coding. I coded CUDA, but that's because I pushed myself down that route. And I feel like having, say a week's course in learning how to use an FPGA would actually give me a lot of understanding and respect for the people who work with them and also the companies that build them. That being said, open source tool chains and FPGA are hit and miss, and
So yeah, I mean they do have these big software stacks now where they say you don't need to learn Verilog and you don't need to do these low level languages anymore.
Vitis and
so Vitis,
Vivaldo.
So I think Xilinx for me was one of the first that really came with this notion of like different levels of accessibility. If you're super kind of up on FPGAs, then by all means go in at the low level. But if you are the kind of AI ML expert and you only want to do Python, you can just do that and we'll make the rest of it work. So there are different levels basically of accessibility. And they were one of the first to speak about this kind of story, which is something that a lot more people talk about now.
Yeah,
this is going back a few years for Vitis.
Having those libraries.
Yeah.
Those intermediate libraries that just do it all for you in the background. I mean, it's like CUDA. CUDA has PTX, which is the low, the intermediate representation before going to machine code, and then FPGA.
Yeah,
but FPGA is coming from the bottom up.
FPGAs have always had this kind of image problem of like it's really hard to do, it's really hard to program and hard to use, and they've been trying to get over that since FPGA started, basically.
And there are so many use cases for machine learning, AI machine learning, that there's not an ideal solution out there. And
absolutely.
if you can program your own.
Exactly. Very specialized. You can be very, very specialized if you can afford it.
You don't need to support IEEE.
No.
Or, you need some specialized security layer on top.
You need pre-processing, filtering or something, FFT or something. You can use other
video.
Yeah, or there's all kind of, or you're doing some kind of scientific crazy thing.
I mean,
you can also do that.
FPGAs, typically the customer base who buy them, they put them in products for 10, 15, 20 years.
Yeah.
And the whole point is not necessarily the reconfigurability when they're installed and sold, but the version 2 of the product uses the same board and the same chips, but different firmware and different configurability, different bit streams. So it's ACAPs feel like they're not in that market. They're in the sort of 2 to 3 to 4 year market that other like GPUs are.
Yes. Yeah. I can see where you're going, with that. I think you're right. But does Xilinx see it that way? I don't know.
I don't know. But I remember meeting the CEO when Versal ACAP was announced just before the acquisition. Great guy, Victor. Definitely, if you've not spoken to him, definitely worth if they'll let you. I'm not sure if he speaks to press anymore.
Yeah, I'm not sure I'm allowed.
They're updating the Versal AI roadmap a lot. A company that's not necessarily updating their roadmap is Qualcomm.
Yes. Yes.
Yes. So Qualcomm
for the data center, not for the mobile stuff.
Yeah. Well, Qualcomm has had multiple generations of smartphone AI processing. We've got latest generation supports Mercantile inferencing. We've got Int4, their tensor accelerators, vector, matrix scaler, the whole shebang. Gen improvement focused on mobile. They have a data center product. I'm not sure if you know about this.
So the AI 100. Please, can we stop calling things 100, especially not a something 100, because you're not fooling anyone. We're not mistaking it for the A100, but please, can we stop calling it a something 100? It's too confusing.
As somebody who deals with NVIDIA a lot, do you deal with Ampere computing as well?
Right. Yeah, no. So for the Ampere A100.
Yeah.
No, I know. It's
that would be a double whammy of disillusionment.
Oh, good grief.
But so Qualcomm's A100, the idea is that they wanted hardware to go into the data center, focusing again on that kind of T4 A2 style 75 watt
inference
workload.
Yeah.
And They announced this chip and they showcased it in a number of edge AI development kits. One of them looked like Wi-Fi. I said this in the episode. Looked like a Wi-Fi access point with a Snapdragon 800 series SoC and a 5G modem. And using their software stack, you could optimize AI workloads. And we thought this is great, for a company that has such an extensive install base of the smartphone stuff. Even though the data center architecture is different, it's still at least holistically taking, on the software side at least, a lot of cues from being able to support it. It was announced in 2019. We've had some updates about it, about deployments, but then nothing. We expected AI 200, AI 300, other generations. And
we expected another generation called H something 100.
Oh, HI 100. That's heterogeneous integration.
No,
chiplets.
No.
So Qualcomm has spoken about chiplets before at conferences.
Okay.
We always thought about it in the smartphone context, so they're not updating the AI hardware right now. But it's one of those things. Qualcomm plays a lot in the telecommunications industry. They have a large need for AI acceleration. I mean, the smartphone division constantly talk about the AI acceleration. So the fact that they have a data center inference product and it hasn't been updated. They do a tech summit every year that I go to in December. No update. Well, that's more consumer focused, I'll admit. I don't know.
We're expecting to see a roadmap by now.
Yeah, there's no roadmap. And we get roadmaps from startups.
Well, yeah, we do, because otherwise people like you and me will savage them if they don't have a roadmap. Yes. We're doing the same to Qualcomm now.
Yeah. And I've worked with Qualcomm extensively on the product side. I've done a couple of sponsor videos for their stuff. And yeah, I am an analyst under retainer from them, but I tell them the same thing I'd tell you on camera, right? It's great to know about this stuff, but always the questions people will ask is, that's great, but what have you done for me lately? What's next? What's on the roadmap? What's going to be the performance like? Are you still working on it? Is this QCT, the technologies division, or something else? And it just hasn't been spoken about. So it could it be that they only did the one generation, decided it wasn't worth it, and it's just slowly going to drift into EOL.
They have multiple kind of power operating points for this thing, so they can go quite low power and still have a good kind of performance per watt figure. So exactly, maybe they're still trying to find exactly the niche. So they can do different things with it, I think. They have reasonable MLPerf results, even claiming they're better than NVIDIA on some slices of it, depending how you slice it, but they're one of the only ones that can even nearly claim that. So I think it's not that it doesn't work. Maybe they're trying to find the niche for it or something. I don't know.
Sometimes these big organizations don't have PR teams for certain parts of it.
Yeah, maybe it's all going great and we just don't know about it.
Yeah. I know. Update the website maybe.
Yeah, tell us more. Tell us more.
So this next company, because as we've been filming today, we've come across a few companies whose names may not be pronounced the right way. This company is called Encharge.
No, I think it's got to be Encharge.
Encharge.
And Encharge. It's about charge and capacitors.
Yes.
So it's got to be about Encharge.
Fair enough.
And they're not French.
Good. No, I will bleep that.
So Encharge. So I unfortunately have not had the opportunity to speak to Encharge yet. It's on the to-do list. Sorry, Encharge, if you're watching. I'm really interested. So they have in their press release 150 tops per watt. Straight away,
you're paying. Insane.
That's absolutely insane. Straight away, we're paying attention.
That's energy efficiency. It's every company's talking about sustainability.
Yeah.
Yeah, 150 tops per watt would be high.
It's just absolutely, insane. So it's a form of analog compute, and it seems like from the materials that they've released so far, it's basically an equivalent of compute and memory, but instead of using the memory cells and operating those at different levels kind of as a variable resistor, they basically have these capacitors that they use. So instead of, using V equals IR, which is for compute and memory, and kind of add the currents together and you get the final, the sum of the the whole of the Mac operations. This is like, let's add the charge together and get the Q, use Q equals CV and somehow make that work into a multiply accumulate. I think I don't know how it works. I don't know how it works yet, but I'm fascinated by the idea. I think it could be really interesting.
I mean, so we were speaking about this before we started filming. Their whole argument is that transistors can be variable and phase change memory can be variable.
So yeah,
and you have to
calibrate and so on.
Post manufacturing calibration. Whereas capacitors, we've been doing phase change memory for about 10 years, really, Chalco glass type stuff. Whereas capacitors we've been doing for decades, so very well defined. You can get them very dense, denser than SRAM to a certain extent. I mean, everybody talks about 1T, 1C SRAM. Well, maybe if you just had 0T, 1C computed memory solutions. So it's also a more linear feedback than a phase change, because phase change does this sort of sigmoidal kind of
thing.
Yeah, and reversibility can sometimes be a bit weird, but so the physics makes sense.
We think it does. If it is what we think it is, we think it does.
The only difference, I think the only complication that they have as a company to communicate is we're using charge, not voltage.
Yes. I mean, they've called the company Encharge. So they're quite upfront about it on Encharge.
Yeah.
Yeah, I can't wait to find out more about how it works.
It's, well, if they're on your to-do list, then...
They're on my to-do list, yeah. Still on the to-do list. Maybe next week.
Tell them to present at a conference, yeah.
Yeah, tell them to come to Hot Chips.
The next processor on the list is one of the kind of weirder Chinese, and I say weird Chinese processors in the fact that because we don't hear much about them.
We just don't have as much visibility.
Because it's China and we're in Britain and the language barrier and, but this is one of the hyperscalers, Alibaba.
Yeah.
Massive online retail giant, of China. And they, much like Huawei has HiSilicon as a semiconductor design company, Alibaba have a subsidiary called T-Head.
Yeah, Honey Badger.
So you were trying to explain this to me earlier, but
T-Head means honey badger, but it's because it's the most ferocious animal.
But why T-Head?
Because I think that's literally what it means in Chinese.
As in,
it's not nothing to do with honey, or it's not a badger, but we call it honey badger. So the Chinese name means T-Head, I think. I didn't name the company. Don't look at me.
No, but the company, it's stylized as the letter T, head, not as in tea leaves. Head.
No.
Is it to do with the Chinese characters for honey badger?
I don't know.
Same as T and head.
I don't know.
I mean, there's a Formula One driver whose nickname is the Honey Badger, and his idea is all ferocious and whatever.
Yeah.
But okay, how does that? Okay.
Anyway, so they have this division called
T-Head, and they've created the Huanguang, and I'm probably butchering that, 800 machine learning processor. And why I say it's a little bit weird is, okay, everybody asks, what are the hyperscalers doing with machine learning hardware? We see Amazon do their Graviton and Trainium and Inferentia chips, and everybody's like, ooh, what is Azure doing, or what is Google doing? Google has its TPU, and maybe they're doing some other stuff that they haven't told us about yet. But what about the others? And then obviously out of the 7 major hyperscalers, they pivot to China. What is China doing? So Tencent has a chip called the Xishao, which was going to be on our episode list until I realized that there's nothing online about it.
Yeah, we don't know anything about it.
One of the companies is doing something called the Yutian. I can't remember which company that is now. I'm sure somebody will tell me in the comments.
Baidu.
Baidu has the Kunlun processor.
Yes. Yeah.
And then Alibaba has the Huanguang 800. because this is the 8th gen. I don't know. In the same way,
But
you
at least it's not 100.
At least it's not 100.
Yeah.
It's 800. So Alibaba came to Hot Chips in 2020 and did a presentation, which is always good because we get into architecture details. And what was surprising, I think, to a lot of people is, okay, it's an inference accelerator, but there's no DDR and no HBM memory.
Yeah.
Lots and lots of onboard SRAM. And there are only a few chips in the market that do that, essentially memoryless. And you, if you do that as a training chip, you're dead.
Yeah, you can't.
Or you need super high speed bandwidth, 2 gigabytes of some other type of very fast storage. But their thing here is that with lots of SRAM, no DRAM, no HBM, no DRAM, no HBM, they can have a deterministic, even though it doesn't sound like a deterministic architecture, a deterministic inference, 0.11 milliseconds on ResNet 50. Normally we'd see something like that from Grok.
Yes.
Regardless of batch size, Grok's whole point is we're a deterministic batch one company. Huanguang does a similar sort of thing. And you'd imagine it being Alibaba, it'd be for recommendation engine focus.
Yeah.
You need every recommendation to be given in 0.11 milliseconds. It's fine. Because if you're loading a bunch of products on a page, if there's one inference that takes 2 seconds, that's sales lost.
Exactly.
And you were saying in an earlier episode about recommendation engines being very different to other...
Very different to other types of AI, yeah. The memory accesses, the embedding tables and so on. It's just a completely different thing.
So, and then you have this trade-off between latency and accuracy. And if your latency is the same, regardless, and you can crank up the accuracy for a retail platform, that's number one.
Every kind of lost fraction of a percentage point in accuracy is like millions of dollars. So they need the accuracy too, right?
Well, which is where the architecture is so interesting because it does reduce precision formats, int8, and I think it even does int4, but int8 and int16 actually, but internally you have this combination of FP24 and FP19, which are not standards. They're quantized formats, yes, but they are not standards.
Can you really get that much benefit from?
Well, so it's
reducing just a couple of bits, or like how does it?
Well, no, if it's so
for 19, I suppose you can increase from FP16.
I'm
like
it's in the presentation they were talking about how they were clamping data points to these internal floating point formats. So if you have an int16 and you want to clamp it to an FP24 or an FP19 value, and the idea is that if your chain is deterministic, then if you can maintain accuracy and you get a higher accuracy result. Again, going back to recommendation engines where that's important, and you need lots of, to your point, embedding tables and SRAM and
all that.
So it's that side of it is interesting for a variety of reasons. What's annoying is there hasn't been an update. We're now almost 2.5 years later. I couldn't find anything talking about a next generation.
But how good is our visibility into Chinese hyperscalers? Again, we might just not know about it. Maybe they've done multiple generations and we just don't know.
Yeah.
It's up to them to announce it before we can talk about
and
it.
Coming to conferences like the Hot Chips or ISSC or whatever. So, yeah. There is... I think, when we do the show next year, maybe one of the angles we look at is this episode is all about recommendation engine focused chips. And we might cover the same ones that we did this year, with any updates if there are any. But
it might make more sense to
concepts around that. So
yeah, I think we should have done it that way from the start.
Sorry,
I'm gonna tell you that now. No, I think it's easier to compare them that way.
Or do we split it by architecture type? Neuromorphic versus an optical and
CGRAs.
What was a CGRA?
What is a CGRA? Yeah, no. Well, we'll see. We'll discuss it.
So, in the spirit of AI,
yes,
for this chip, I'm going to show the picture on camera of what we just made in Midjourney because it's very appropriate.
Okay, yes. Korean company, and they've chosen the name Furiosa AI, which I guess means they were having a drink one night and they'd just been to see Mad Max, and they're like, this kind of dates the company, I guess.
Yeah.
What should we call our company? What's awesome? And
well, no, the new Mad Max, clearly.
well, the new Mad Max, yeah. So they've called the chip Warboy as well, another Mad Max reference.
Yeah.
So I know we're laughing about it in the segment earlier, like what are they going to call the
next
chip, the next generation? Or do we have to wait for another Mad Max movie to come out in the franchise?
I mean, Mad Max itself is a whole, world in of itself and lore and whatever. And I watched the film. I didn't do anything else with it. So, yeah.
Well, it's an interesting move to name your chip after a character from a movie that instantly dates it.
A desolate wasteland where water is the most important resource. Here we have our new processor from Furiosa AI, the Warboy. You're like,
they're kind of sick as well. Like they're all kind of, ill from the radiation and stuff in the movie.
Oh, you're talking about the movie, not the employees.
The movie, not the company. But yeah, I'm not sure I would have chosen that movie to base my entire company on. But
at least it's different.
At least it's different. It's memorable, and kudos for not putting AI, trying to shoehorn AI into a word with with an A in.
Yeah.
As well.
There's been a few of those.
There's a few offenders, that we've already spoken about, but you know who you are.
FuriosaAI.
Furiosa. So this is a 64 tops. It's going up against the A2, NVIDIA A2.
Right.
So kind of lower kind of entry level servers and so on. So they're up against NVIDIA's A2 in that 40 to 60 watt TDP. I think 5G infrastructure, industrial kind of edge boxes and so on.
Density edge.
Yeah, kind of edge server,
edge
box, kind of edge server. But also in data centers where maybe they don't want to spend that much.
Right. Okay.
For some of these inference kind of installations.
Yeah.
They have a ton of MLPerf results, which is cool. Kudos, because it means we can see what you've been working on, the improvements that you've made. So it seems like, they're doing well. They have they have a roadmap per se, but they've said they're going to do another generation, supposedly 10x the performance, but we'll see what happens with that one.
10x in a generation, not industry standard 7%.
Well, they might just be making it bigger.
Oh, okay. It's now a 400 watt chip.
Yeah, exactly.
Yeah,
it might not be
enough.
10x more efficient. It might just be 10x bigger.
Oh, okay. Well, fair play. Big chips always work.
Big chips is always a thing. But yeah, we're watching to see what they're going to do next and what they're going to call the next chip.
Yeah. Answers, suggestions in the comments below, and we'll compile the best. And if we can, we get Sally on camera with the CEO to go through the list of...
Here's what we think you should name.
Here are the audience recommendations for your next generation product.
They never agree to that.
No. Well, for one, you might need a translator. And some things may not translate. That's always the worry with these weird...
Yeah.
The Asian companies that name, slightly off the beaten path. You're like, do people...
kudos for choosing something memorable, definitely. Yeah. Something different and something memorable. And I guess they're a young company of young people, and they...
The product's called the Warboy because when you're in a dense server, you need 10, 20, 50 of the Warboys.
Right! Now it all makes sense.
And you need to ride into battle.
Now it all makes sense.
Against the people stealing the water. I don't know. I think the analogy breaks down.
At that point, yeah. Maybe we're reading a bit too much into it.
Yeah, maybe.
Maybe we are.
Maybe. So if you've got any other fun name companies and products, I think we want to hear about it, especially if they do machine learning processors.
Yes, we do. Yeah.
But I'm glad you've all stayed to the end of this episode. There's going to be another one right around the corner, if not already in your up next box. So go click on that now. Don't forget to like and subscribe. Obviously, follow Sally over at E Times, and we'll see you in the next episode.